If you were to take every single atom that makes up your body, every star in the sky, and every grain of sand on every beach on Earth, and compress them into a single point, you would have the seed of our entire reality. But what if I told you that, according to the laws of physics, this entire existence shouldn't actually be here? Image, a close-up of a human eye reflecting a swirling, vibrant nebula in the dark of space. We live in a universe defined by a precise, almost impossible balance. If the force of gravity were just a fraction stronger, the universe would have collapsed back into a singularity mere moments after it began. If it were a fraction weaker, stars would never have formed, leaving the cosmos as nothing but a cold, thinning soup of hydrogen. Image, an animation showing a slider bar adjusting the strength of gravity, with the universe either imploding or dissipating. How did we get so lucky? Or is luck the wrong word? Today, we are peering into the grand machinery of the cosmos to understand why the universe is the way it is, and why the deeper we look, the more we realize that our existence is a statistical impossibility. Image, a wide, sweeping cinematic shot of the Milky Way galaxy spanning across a night sky. Image, a 3D render of the Big Bang, showing a tiny point of light exploding into massive clouds of cosmic dust and gas. For most of human history, we looked up and saw a static stage. The stars were fixed, the planets were wanderers, and the universe was, for all intents and purposes, eternal. It wasn't until the early 20th century that we realized the stage itself was moving. Image, vintage archival footage of Edwin Hubble looking through a large telescope. Edwin Hubble discovered that the universe isn't just sitting there, it's expanding. Every galaxy is rushing away from every other galaxy, like dots painted on the surface of an inflating balloon. Image, a CGI animation of a balloon being inflated with black ink dots on the surface, representing galaxies moving apart. Image, a photograph of the deep space field captured by the James Webb Space Telescope, revealing thousands of tiny, distant galaxies. If you wind the clock backward, everything converges. The galaxies come closer, the space between them vanishes, and eventually, the temperature rises to unimaginable levels. We call this the Big Bang. But the Big Bang wasn't an explosion in space, it was an explosion of space. Image, a high-contrast graphic showing the progression of the universe from a hot, dense state to the current era. Image, a close-up of a scientist in a laboratory looking at complex mathematical equations on a whiteboard. But here is where the math gets haunting. When we look at the amount of matter in the universe, we see a massive discrepancy. We see galaxies spinning so fast that they should fly apart, yet they don't. Something invisible is holding them together. We call it dark matter. Image, a visualization of a dark matter web, looking like a glowing, interconnected neural network in space. Image, a glowing, ethereal structure representing dark matter surrounding a visible spiral galaxy. Image, a close-up of a complex galaxy cluster showing gravitational lensing distorting light. We can't see dark matter. It doesn't emit light, reflect it, or absorb it. We only know it's there because of its gravitational footprint. It makes up about 27% of the universe. Image, a pie chart graphic displaying the composition of the universe, dark energy, dark matter, and normal matter. Image, a stock shot of a dark, empty room with a spotlight illuminating a single floating particle. Then, there's the even weirder one, dark energy. It makes up 68% of the universe. It's not just sitting there, it's pushing. It's causing the expansion of the universe to accelerate. Image, an animation showing space stretching and pushing galaxies away from each other at an increasing rate. Image, the digital representation of space-time fabric bending and curving under the influence of unseen forces. Image, a futuristic laboratory set up with lasers and high-tech equipment. So, the universe is mostly made of stuff we can't see, don't understand, and can't explain. And yet, the normal matter, the stuff that makes up you, me, and your coffee cup, is just a tiny, lonely sliver of the pie. Image, a microscopic view of atoms vibrating in a crystalline structure. Image, a high-definition shot of a sunset over the horizon of the Earth from the International Space Station. Think about the conditions required for life. You need stars to forge carbon, oxygen, and nitrogen in their cores. You need those stars to explode as supernovae to distribute those elements across the cosmos. You need a planet at the perfect distance from a stable star, with a magnetic field to protect it from solar winds. Image, an artist's impression of a supernova explosion casting bright light across a dark nebula. Image, a diagram showing the Goldilocks zone around a star, where life could theoretically exist. Image, a close-up of a glowing, molten planet cooling down over millions of years. This process takes billions of years. If the universe were any younger, there wouldn't have been enough time for these heavy elements to form. If it were much older, the stars would have burned out, leaving the universe in a permanent, icy darkness. Image, a time-lapse of a star's life cycle, from bright birth to a fading white dwarf. Image, a conceptual image of the heat death of the universe, featuring cold, dim embers in an endless void. We are effectively living in the stelliferous era, the brief, golden age of the universe where stars are still burning. We are the lucky ones who arrived at the party just as the lights were turned on. Image, a montage of human life, bustling cities, and technological progress intercut with astronomical imagery. Image, a close-up of the sun rising over the jagged, frozen mountains of Antarctica. Image, a digital render of a quantum field where particles are popping in and out of existence. But there is a darker truth hidden in the physics of the vacuum itself. Quantum mechanics tells us that the vacuum of space is not empty. It's buzzing with energy. Virtual particles pop into existence and annihilate each other in the blink of an eye. Image, a diagram of quantum fluctuation showing particles appearing and disappearing rapidly. Image, a scientist pointing to a computer screen displaying complex simulation data. When we calculate how much energy should be in the vacuum, we get a number so large it's impossible to comprehend. But when we measure the actual expansion of the universe, the number is smaller by a factor of 10 to the power of 120. It is the greatest error in the history of science. Image, a large, bold number 10 to the power of 120 fading into a dark, starry background. Image, a shot of a massive radio telescope dish aimed towards the depths of space. Image, an abstract representation of multiple, parallel universes branching out like a tree. Some physicists suggest the answer lies in the multiverse theory. Maybe there are infinite universes, each with different laws of physics. Some have gravity that's too strong, and they collapse. Some have gravity that's too weak, and they never form stars. Image, a visual of bubbles floating in a void, each bubble containing a different galaxy structure. Image, a CGI shot of a universe colliding with another, creating a ripple effect in space-time. Image, a close-up of a human brain with glowing neurons, mirroring the structure of cosmic filaments. We happen to be in one of the few universes where the conditions were just right. It's the anthropic principle, the idea that we observe these conditions because, if they weren't this way, we wouldn't be here to observe them at all. Image, a silhouette of a person standing on a cliff, looking up at a breathtakingly clear, starry sky. Image, the wide shot of the Earth seen from the moon, emphasizing our isolation and fragility. Image, the high-tech laboratory animation showing the collision of particles in a Large Hadron Collider. But does that satisfy our need for meaning? The fact that we are a statistical fluke in an infinite, uncaring sea of bubbles. Image, a dark, moody shot of an astronomer sitting alone in a dome, working late at night. Image, a fast-paced montage of historical scientific discoveries, from Newton to Einstein. Image, an animation of the expanding universe, zooming out further and further until the galaxies are just tiny specks. It can feel lonely, but it is also deeply empowering. We are the universe trying to understand itself. We are star stuff that has gained the ability to contemplate its own origin. Image, a close-up of a human hand reaching out toward a light source. Image, a shot of a massive galaxy cluster, glowing with internal starlight. Image, a cinematic drone shot flying over a vast, desert landscape at night. The revelation here isn't that the universe is broken, or that it's a mistake. The revelation is that we are the observers who give the universe its meaning. Without us, it's just cold gas and dark energy. With us, it is a grand, beautiful story. Image, an animation showing the cosmic web connecting to a human eye, symbolizing observation. Image, a fast-forward sequence of the Earth's orbit, spinning gracefully. Image, a shot of a child looking through a small telescope in a backyard. If the universe is as fine-tuned as it seems, then every one of us is part of a grand experiment. We are the rare exception to the rule of chaos. Image, a cinematic shot of a sunset casting long shadows over a futuristic space station. Image, an image of the Voyager Golden Record spinning in space. Image, a wide-angle shot of the night sky, with a meteor streaking across the frame. We have spent the last few minutes traveling through time and space, from the moment of the Big Bang to the cold reaches of the distant future. We've looked at dark matter, dark energy, and the tiny, precious window of time in which we exist. Image, a slow-motion shot of water droplets falling into a pool, creating ripples. Image, an illustration of the different eras of the universe, from radiation to the era of stars. Image, a shot of a globe slowly rotating in a darkened room. But the journey doesn't end here. Every discovery we make, every telescope we launch, and every equation we solve, brings us one step closer to understanding the grand design. Image, a CGI artist's rendering of a futuristic spaceship traveling through a nebula. Image, a close-up of a telescope aperture opening and closing. Image, a beautiful, vibrant, high-definition nebula filling the entire frame. If you enjoyed this journey into the unknown, make sure to hit that subscribe button and click the notification bell. We dive into the mysteries of science every single week, and we don't want you to miss what's coming next. Image, a call-to-action graphic with a subscribe button animation and a like icon. Image, a transition screen showing links to other related documentary-style videos. Image, a final shot of the Earth as a tiny blue dot suspended in the darkness of space. Image, a fading, black screen with white text that reads, "The universe is waiting." Image, a shot of an empty, starry sky that slowly fades to black. Image, a small, glowing light in the center of the screen that slowly pulsates. Image, the final frame showing the YouTube channel logo. Image, the screen fades to black.